In this lesson, we'll talk about one of the higher difficulty questions that you'll find on the executive assessment that honestly the test tries to use to shock and awe you into thinking something is harder than it really is. Functions and symbols. So here we have our basic function notation. And the way that this is written is you basically have a function that dictates operations performed on some variable, in this case, x. And it's read as f of x. And the function of x is the same as y is equal to something in the coordinate plane. Again, the coordinate plane as a concept can be tested on this exam, even though there is no plane geometry. So this is just saying that when you plug in some value for x, you're guaranteed to get some outcome because you're going to have to do x plus 1 over x no matter what x is. And if you have what are known as nested functions, you have to process them from the inside out. So always begin inside and then work your way out if you've got a nested function, because that's basically applying the parentheses as the first step in the order of operations. So let's take a look at an example. We've got this notation here of the f of x is equal to x plus 1 divided by x. And we're being asked in this example, what is the f of 2, or sorry, the f of 2, because we got to find the f of 2, and then we've got to apply the function again to whatever that result was. So the f of 2 is going to be 2 plus 1 divided by 2, which of course is 1.5, or 3 halves. Then we have to take the f of 1.5, or 3 halves. And if we do 1.5 plus 1, that's going to be 2.5. And 2.5 divided by 1.5 is going to be either 1.667 or 5/3. Because if you've got 2.5 over 1.5 in your fraction, you know you can't have a decimal inside of a fraction. So you just multiply the 2.5 in the numerator and the 1.5 in the denominator by 2 over 2 to get 5 over 3. So this is just a very basic function example. Now, the implications of functions. Functions always have what is known as a domain, and those are the acceptable inputs that produce real values in the function. And we remember from other lessons that for the executive assessment, there are no non-real values. Everything has to be representable on the number line. So the domain of this function would be any value where x is not 0 is accepted, because if x were equal to 0, we would be dividing by 0. And we remember from another lesson that when you divide by 0, the technical result is actually infinity, and infinity is a non-real value, which is not accepted on the executive assessment as a result. And that's actually a good thing because there's a lot of complexity that gets involved there. So that's a net positive for every test taker that we can't divide by 0. And your primary EA domain constraints are going to be that you can't divide by 0 and you can't square root a value less than 0. Because if you were to square root a negative, you end up with an imaginary number, because we know that any square root is supposed to produce two values that are the same. And of course, you have to have a positive and a negative to produce a negative product. So you cannot square root a negative on this test either. That would be outside of any domain for a function. Now, then we talk about symbols, and these weird symbols are certainly one of the things that most flummoxes students at the outset. But the first thing to recognize is that these just represent arithmetic or algebraic operations that are defined by the exam. They are not necessarily defined rules of math. So if you're looking at that weird like blue cross that's on the screen, that's not some arithmetic operation that you missed someday in 6th grade. That is being defined proprietarily by the test in the problem that you're working through. And basically, these are just follow the instructions kind of questions. So you just follow the format as presented, and they're similar method to functions because you just have to follow the steps of whatever the symbol is said to do. So strategically, first, stay calm. These problems are intended to shock and awe you and make you go, what is that? And overreact. Instead, just say, they have to tell me what is necessary to solve. So I'm just going to read carefully and work through the problem. Recognize that that initial shock and awe is potentially the most difficult part of the problem. So then you just note that that symbol function is probably not predicated on any defined rules of mathematics that you know, but it is going to have to follow whatever the rules are as they are articulated. So you just have to apply the rules of mathematics to these symbols as dictated by arithmetic or algebra. So the order of operations is in play. You have to make sure that For instance, if I multiply A times B, that's the same as B times A. All of these sorts of things are going to be relevant, but you just have to work through the problem very carefully and you'll reach the answer. So let's see how we'd work through a sample unfamiliar symbol question. So we've got this, if this diamond, we'll call it a diamond, represents a unique digit in the equation 5 diamond diamond plus diamond diamond is equal to diamond 32. What is the value of that diamond? So first, stay calm, literally. That's the first and most important step. Now you want to begin with the known information. So we know that we've got 500 something plus a 2-digit integer is going to equal a 3-digit integer ending in 32. That is given. So then we have to think about what that means. If the diamond is a unique digit, it can't equal 5, because if it's already in the problem, it can't be 5, it can't be 3, it can't be 2, because we're told that it's unique. It's not already there. The only other possible hundreds digit when you add a 2-digit value to 5 has to be 6, because if I'm adding 2 digits, a 2-digit number, it's going to be less than 100. So I can't get up from 500 something to 700 something, for instance. So that means that the diamond has to be 6. And sure enough, if we just confirm the approach, we know that 566 plus 66 is in fact 632, because if we do 566 plus 6 gets me to 572, plus 60 is 632, and that satisfies all conditions of this unfamiliar symbol problem, even though we had no idea what it meant to start. So the first step of the symbol and function process, set up the scratchpad as you always do, carefully read and define the function or symbol as presented to inform the problem solving or data sufficiency processes. These obviously can be both problem solving and data sufficiency formats. So just be careful as you set everything up as normal. Then step 2, carefully apply that function or symbol as required by the problem. You should use an example to illustrate the function or symbol if needed. In the previous case, we probably didn't need to do that. We just started working through the constraints of the problem. But if you have any doubts as to what it means, use an example. And then you have to consider the logical implications of the function or symbol once you define it, of course. Then step 3, consider the best approach for solving. Take a technical or logical path to solving if you can, like we just did. You're like, okay, it's got to be 6, right? Just think about it in that logical fashion rather than being overwhelmed. And consider plugging in the choices or easy values to model as a frequently viable approach, because oftentimes you're going to be able to use alternative tactics. And honestly, in a lot of function or symbol problems, the entire point is to plug in values anyway, because that's how a function works. So allow yourself to model, allow yourself to backsolve as the problem allows, and you'll be able to knock these questions down a peg, because they honestly are often a differentiator for a 150 plus on this exam, because the exam doesn't necessarily think that these weird symbol and function problems are that difficult, but students do. So they're a great opportunity for you to separate yourself from everybody else by just remaining calm and executing the steps of the problem as we've outlined. So let's move on over to the whiteboard, take a look at a couple of examples together so you can see how this process is going to work in practice. Here we have a sample problem solving question. So we'll set that up the same way as we do every time. And we're going to put our little line over top for what the question is asking for. In this case, I've got relatively complex expressions. I'm not going to write those out as part of my process. But we see what we're being asked for if we skip to the end. We're being asked for the value of f of x squared. Now, as I mentioned, in general, it's best to set up the technical approach first. So we know that we nest the functions. So we know that if we're looking at the f of x squared, that stands in for the x. So that's going to be f of x squared is equal to 1 minus x squared squared. And of course, if we just distribute that exponent, we get 1 minus x to the 4th, and that's our answer, and it's really fast. So try the technical approach. But if we don't do the technical approach, we can still solve the problem, and that's by just plugging in an easy value. So in this case, we can see we've got 1 minus x squared, and we've got all of these 2's and 4's and 1's. We want to avoid values that are in the problem. So let's just say x is equal to 3. Because if x is equal to 3, then we know that x squared is equal to 9. And we've got f of x is equal to 1 minus x squared. So we're looking at the f of x in this case as being equal to 1 minus 3 squared, which would be negative 8. And then with our f of x squared, well, that's going to be 1 minus now 9 squared. So that's going to be 1 minus 81, and that's going to be 80. So we know that when we plug in our value of x, we should be able to get a result of 80. And x, remember, was 3. So if we're looking at choice A, that's 1 minus x to the 4th. So that's going to be 3 squared. And of course, that's going to be 9 squared. And that's going to be 1 minus 81. And there's my 80. Now, on the exam, go ahead and at least test the rest of them to make sure there's no duplicates. But if I'm looking at choice, and that's, of course, negative 80, should be negative 80 as I said it through. And so then we've got to take a look at choice B. Well, here we're going to have a positive. That's greater than 0. I don't even need to test that. That's out. Same thing with choice C. I need a negative value. Same thing with choice D. Same thing with choice E. So we can solve this through modeling as well, just quickly knowing that we got negative 80 as our result. So when we got negative 80 as our result, we just have to go find which other answer choice when we plug in 3 produces negative 80, and then we're basically done. So again, as I mentioned, these aren't necessarily the hardest questions. You just have to be savvy in solving. So let's go ahead and take a look at a data sufficiency to close this lesson as well. So we've got a weird symbol here, and we start with what we know. We know that for any two unique positive integers, A and B. Okay, so A does not equal B because they're unique, and we know that A is greater than 0 and B is greater than 0. Take notes on all of the facets. We then learn that A weird little rectangle symbol B is equal to the GCF for greatest common factor of A and B. So then we discover that X is less than Y, and we're being asked X with the little rectangle symbol Y equals question mark. So we box that off. And we need to know what the GCF or greatest common factor of X and Y is. So condition 1 says that X is equal to 16. Okay. Well, 16, if y is equal to 32, the greatest common factor is 16, because 16 goes into 32. But if 16 and 30, well, then we know that it's just going to be 2, because 16 is divisible by 2, and that's a factor of 16, and 2 is a factor of 30, but nothing else would be. So we've got multiple possible outcomes, and so condition 1 by itself, not sufficient, and we're down to B, C, and E. Then condition 2, we get 17 is y. Well, if y is equal to 17, we know that x had to be less than y. So x has to be less than 17. So now we've got to consider what are the factors of 17. And the factors of 17 are going to be equal to 1 and 17 only. And we know that x had to be less than 17. So the greatest common factor of 17 and anything less than it is 1, which gives us exactly what we needed to solve the problem and makes condition 2 by itself sufficient, and we can select choice B. So you can see both of these examples at the first glance seem quite complex. What are these weird symbols and functions? But that's the exam taking advantage of your assumptions and trying to make you think things are harder than they really are. That is a really important skill for you to have as a manager. So that's why this is a common tactic of the executive assessment. Remain calm, work through the steps of the problem, and these weird symbols and functions will become part of your path to getting the score you need to attend your target program. Go ahead and practice some of these problems on your own to improve these skills for your official test date.